Alright, would you like to read our I can statement? Really, really loud. Okay, so yesterday we found the same thing. We can find a product of a whole number and a fractional part, right? Okay, and we saw that we could do a visual model, right? Okay, so well, I don't want to do 3/4, I'll do 12. That's easier.
So used to the other
Yes, I am. Okay, so what did we do yesterday? How did we model 12 times 3/4? Yeah, we did it with arrays, right? And we can say this is, excuse me, 3/4. What word do we use here? 12. Okay? So we need to have an array that has a total of what? 12. But it has to have a factor of 4. So what can our array be that has a total of 12 and has a factor of 4? Really? Okay, not 4/3, but 4 rows of 3 or 3 rows of 4. Which should we do? 3 rows of 4? Okay. Now what do I need to do? Yep. Need to make it into a rectangle. And I'm going to cut it into what size pieces? 4. So which way can I cut it into 4? Leah. Down. 1/4, 2/4, 3/4, 4/4. Good. And how much of that am I going to color in? Lee. 3 of them, because this is 1/4, 2/4, 3/4, right? So 3/4 of 12 equals 9. How many felt like yesterday's assignment you understood? Good. Okay. Well, I'm going to show you, so that's the model. I'm going to show you the algorithm. Remember, I like to teach you different strategies so that you can choose which one your brain, okay, wants. Okay, so if I have 12 times 3/4, okay, what is this number right here? 12. It's 12 wholes, right? Okay. Now remember, fractions is division. It really is just dividing. We're dividing them into smaller pieces. So what could I have? I need to make 12 a fraction, but it still needs to equal 12 wholes. What can I do to make 12 a fraction that still equals 12 wholes? Okay, I wondered if someone. Hey, tell me what 12 twelfths is. 1 whole. Equals 1. I need it to equal 12. So how can I make it a fraction and it will still be 12? Now let me tell you this. What is this? Say it with me. 12 divided by 12 equals 1. So with that same concept, I need to say 12 divided by what gives me 12? Hold it up. Hold it up with your finger if you know what it is. Hold it up. Good. I see lots of ones. Is 12 divided by 12 1? Mm-hmm. Yes. So anytime I need to make a whole number of fractions, what do I put it over?
1.
1. No. If I put it over Excel, it now equals 1. You would hate that, right? If you needed a fraction with $100, and your boss said, okay, I'll just put it over Excel, now I owe you how much?
1.
$1.
That's
He's like, yes, I just saved $99, right? So what do I do for 100 to make it a fraction?
put over 1.
Put it over 1. Good. Does everybody understand that? Okay, good. So if we do that, 12 over 1 times 3/4. Okay? Now, remember, I say we do different things for adding and subtracting of fractions and multiplying and dividing. Okay? Adding and subtracting, what do we have to do? If it was this,
Find a common denominator.
yes, I have to find a common denominator. Okay? That's adding and subtracting. This is where you've got to start making these files in your brains of how do I work with fractions. Okay? Make a file. Adding and subtracting fractions, I find a common denominator. Multiplying, dividing fractions, they need their separate folders in your brains. Okay? Because we do two different things. So, when we multiply fractions, we multiply straight across. Okay? Let me say that again. When we multiply fractions, we multiply straight across. Okay? So, 12 times 3 is 36.
1 times
1 times 4 is 4. Okay? Again, when we multiply fractions, we multiply straight across. So now are you going to go back like this? And do this? 12 plus 3 is 15, 4 plus 1 is 5.
No.
No, please. Two different folders in our head. One folder for adding and subtracting, one folder for multiplying. And then we'll create another folder for dividing. Okay? Don't start doing this. Or that. Okay, so can I do the 36/4?
No.
No. What is this fraction? Say it. Or not. Okay, say it.
36 divided by 4.
Oh, let's say it again.
36 divided by 4.
Equals?
9.
Oh, is that what we found?
Yes.
That is what we found, right? Hey, let's look at our, oh, no, I want to show you one other thing. Okay, now if this confuses you, you stick to this. Multiply across and simplify. Okay, but we have a trick or a, what else do you want to call it? So we'll just left my head. Shortcut to getting the answer. Okay? And it's called cross canceling. So what you're doing is you're going to start, so we got a division problem here, right? Well, we're going to do some division in here before we even multiply. Okay? So if it's cross canceling, we're looking at those two numbers and those two numbers. That's why we call it cross canceling. Is there anything that we can divide 1 and 3 by? That's going to change the answer. No. Yeah, 1. Is that going to change our answer? No. Is there anything that we can divide 12 and 4 by? 4. We can't do 3, right? 4 cannot be divided by 3. But we can divide both of them by 4, right? So what's 4 divided by 4? So I'm going to cross that out and put 1. But I have to do it here too. I can't just do it on the one side. What's 12 divided by 4?
3.
Now cross that out and put a 3 there. Now, can either side be divided anymore?
No.
No, because they both have 1. Once you get to 1, you're good. Okay, now I can multiply. 3 times 3 is 9. 1 times 1 is 1. What is 9 over 1?
9.
9 wholes. Did we get the same answer?
Yes.
Yes, we did. Good. Hey, let's look at number 1. Earl bakes 3 loaves of bread. He keeps 1/4 of the bread for himself and gives the rest to his neighbors. How many loaves of bread does Earl give to his neighbors? Okay, so he bakes 3 loaves of bread. Write 3 loaves of bread in there. Okay, he keeps 1/4 of the bread for himself. So what do we need to cut our loaves of bread into? 4. 1, 2, 3, 4. Okay. Is there a way, now I'm going to get a different color, to make this into an array?
Yeah.
How?
3 rows of 4.
We have 3 rows of 4. Good. So if I put my rectangle around there, can I cut this into 4s? So we're really finding out what 1/4 of what? 3 is, right? Okay. What does up tell us to do?
Multiply.
Multiply. So we're really finding what 1/4 times 3 is. Okay. So then when it asks us tomorrow, is there a way that I can cut this into 4s?
No. Actually, yeah. Down.
Down. Here's 1/4, 2/4, 3/4. Now remember, these are just our dots that we did yesterday.
Yeah, that's all it is.
That's all these are is our dots from yesterday. Okay? Does everybody see how we got that? Okay, it says, how many loaves of bread does Earl give to his neighbor? Well, he keeps how much? 1/4. So what am I going to color in? One of these 4s, right? So how many does he keep? 3. So how many loaves does he, how many slices does he give?
3.
Oh, look again.
9.
He keeps this.
9.
Okay, so 9 what?
9 slices.
Okay, 9 slices. So we cut them into slices of 4s. So what does he give? 9/4 of the bread. Right? Now, can we keep that like that? No. So what do we need to do? We've got to change it into a what? Mixed number. How do we do it?
You can either divide or take those out.
Yeah. We can either divide or we can take wholes out. What should we do?
Take holes out.
Okay, what's a whole in 4s?
4/4.
4/4. So I'm going to take out 1 whole. What's 9/4 minus 4/4? 5/4. Can I take another 4/4? Yes, I can. What's 5/4 minus 4/4? 1/4. So what do I have? 2 and 1/4. Right? 2 and 1/4. So this is Wrong. Okay, so he changes friends 2 1/4 loaves. Okay?
Wait.
It said he kept 1/4 of himself.
I know.
So he gave his friends 2 1/4, right?
Well, he kept 1/4 for himself and he gave the rest away to
Right.
his neighbors.
Exactly, but it's important. Exactly.
Okay.
It's right. Exactly.
I understand where I'm going.
Yeah, this is what he kept right here. Is where it's green.
Uh-huh.
This is what he gave away right here. Which, if you were to put all these slices back together, there's 1, 2, 3, 4. There's a whole loaf, right? Here's 1, 2, 3, 4. Here's another whole loaf, right? And then we have what?
What?
So 2 1/4 is what he gave away.
See where I went wrong now.
Okay, good. Let's flip the page. Mrs. Fan bakes 2 cakes, each in the shape of a hexagon. She takes 3/4 of the cakes to the party. Determine how much cake she takes to the party using pattern blocks. But we're not going to use pattern blocks, we're just going to use models. Okay? Alright, so how much did she do? What did she do? Uh-oh.
Makes 2 cakes.
2 cakes. Good. She bakes 2 cakes. There's our 2 cakes. Dropped. She takes 3/4 of the cakes to a party. So what are we going to cut our cakes into?
Fourths.
Fourths. Okay? So she takes 3/4 of the cake. So we're finding out 3/4 times 2. Okay? All right. Can we make this into an array?
Yeah.
How are we going to do that?
Make it.
Oh, I've got Lee and I've got Regan to know. I need the rest of you to show me that you're understanding. How are we going to make this an array? We've already cut it into. We're trying to make it into an array. Remember, these are the dots, like we did yesterday. Put a box around it. Good. And we want to cut it into what? Fourths. How can we cut that into fourths? Going down. Good. Good. Now it says she takes 3/4. How much am I going to color in? 3. Okay. So how much did she take? Let's talk in just fourths right now. How much did she take?
9/4.
3/4.
Oh. She took all this that's highlighted.
6/4.
How many pieces are there? 1, 2, 3, 4, 5, 6. So she took what?
6/4.
6/4. Right? Can we leave it like that?
No.
No. So we can either divide or
Take out whole.
take out whole. What do you want to do?
Take out whole.
Take out a whole. 6/4 minus 4/4 equals
2/4.
2/4. Can I take out another whole?
No.
No. So I have 1 2/4, which is actually
1 1/2.
1 1/2. Okay? So 1, 2, 3, 4. There's a whole cake. And then I have 2/4 left over, which we know is 1/2. Does everybody see the model? Okay, let's look at the algorithm then. 3/4 times 2. Remember, what do I need to do first? Put it over a 1, right? Anything that's a whole over 1 is still a whole. Now, I'm multiplying. What am I going to do? Multiply straight across. 3 times 2 equals
6.
4 times 1 equals
4.
Oh, did we get 6/4? We did get 6/4. Can we leave it?
No.
No, when we're not going to do 6 divided by 4 is what? 1. 1 times 4 is 4, subtract. That now becomes my numerator and my divisor is my denominator. Okay, everybody see that?
Yes.
Let's cross cancel. Is there anything between those two numbers or those two numbers that can be divided out?
Between 4 and 2, there's 2.
Okay, 4 and 2. Both 4 and 2 can be divided by what?
2.
2. 4 divided by 4 is, 4 divided by 2 is?
2.
2. 2 divided by 2 is?
1.
1. 3 times 1 is? 3. 2 times 1 is? 2. Yeah, that didn't give us, didn't put it in a, we might not, we just have to quickly put it into a mixed number. What are we going to do? Take out a whole. What is a whole? 2 twos. 3 minus 2 is? Or 3 halves minus 2 halves is? 1/2. Remember that. 1/2. Okay, so we have 1 1/2. Look, it's already simplified for us. Okay, all right. Let's look at one more. Rashad bakes 4 equal-sized granola bars. He serves 2/3 of the bars to his friends. Let's just talk algorithm. What are we going to do to find how many granola bars he serves?
4 bars times 2/3.
So let's just, we're doing a whole number by a fraction. Remember that was our, so what's it going to be?
4 times 2/3.
Oh,
4 times 2.
4 times 2/3. Good. Tell me how we do it. Someone other than these two. They've been with me all morning long. Put the 1 over a 4. Good. Then what? Multiply straight across. Do I want to ask anything before I multiply straight across? So I've got someone playing with their books, playing with their hands. You gotta pay attention, guys. Okay. Oh, we're multiplying, so do we need to find a common denominator? That's in a different folder, right? That's in our add and subtract folder. We have dived into our multiplication folder. So what do? Yes, can we divide anything out? Can we divide anything between 1 and 2? No. Can we divide anything out between 4 and 3? No, they don't have anything that can be divided, right? Equally to them. So we're going to multiply straight across. 4 times 2 is? 3 times 1 is? 3. Okay? You guys prefer to take out wholes. I prefer to divide. It goes a little quicker. 8 divided by 3 is what? 2. 2 times 3 is?
6.
6. 8 minus 6?
2.
2. That now becomes my numerator and my divisor is? 5. Oh, 2 and 2/3. Can that be simplified?
No.
Why?
3 cannot be divided by 2.
No. Why? The numerator is 1 less than the denominator. Good. Hey, I want to see how you're feeling about this. Fist to 5. Okay, I want to see this real quick as a check off. Either on a piece of paper or whoops. 3 times 5/8. Go. Write it somewhere. If you need to, it's on on page 188, it's number 3, 2 times 5/8.